This presentation will briefly outline a way to accelerate the global energy transition by combining geologic hydrogen with complementary technologies that can be implemented on a large scale in many countries in the world. To begin, I will highlight a key current climate trend and a UN statement on the need for substantial climate action. Then, I will introduce a major study by a US government agency about a relatively new clean energy resource that can be utilized on a very large scale. As shown in the graph on the left, carbon dioxide levels in the atmosphere are rising at increasing rate. The graph on the right is showing the amount of CO2 emissions in billions of tons per year estimated by the Global Carbon Project. The latest year shown in this graph is indicating that approximately 38 billion tons of CO2 were emitted globally in 2023. Since the amount of CO2 emissions are continuing to increase, it appears that total energy demand is rising faster than renewable energy generation. As a result, much greater climate action is required, which is summed up by the UN Secretary-General, Antonio Guterres, who said, "Our world needs climate action on all fronts, everything, everywhere, all at once." Naturally occurring hydrogen can be extracted directly from the earth and has been given multiple names including geologic, natural, white and gold hydrogen. As well, it also can be generated in certain rock formations. When it is generated this way, this type of geologic hydrogen is referred to as orange hydrogen. The U.S. Geological Survey has completed a major study and has estimated that the Earth holds over 5 trillion tons of this type of naturally occurring hydrogen in underground pockets, which is an extremely large amount. They also indicated that a few percent recovery of this amount would still supply all the projected demand for hundreds of years. There is already a commercial site producing geologic hydrogen near Borakabugu, Mali. It started production in 2012. Geologists have reported that they have found or soon expect to find geologic hydrogen reserves in various locations including Canada, US, Australia, France, Albania and Spain. As a result, geologists are predicting a natural hydrogen gold rush. The progress in developing projects to extract hydrogen directly from the earth is impressive. For example, Gold Hydrogen has been developing a project in Australia and has indicated that they estimate that they can produce geologic hydrogen for approximately $0.66 per kilogram. As well, it has been reported that a US-based company, Coloma, has recently raised $330 million in 2024 to develop geologic hydrogen projects. And finally, it has been reported that Chapman Hydrogen and Petroleum Engineering is developing a geologic hydrogen project in northern Ontario. To accelerate the process of finding geologic hydrogen, artificial intelligence or AI services can be used to review available data relating to land resources around the world, including data from satellites, to determine an initial set of areas that could then be reviewed further by experts to determine the best locations for exploration. When doing so, these services can analyze available data for many parameters including the best geological formations, proximity to a potential electrical grid connection, proximity to markets including population centers, access to adequate roads to transport equipment, supplies and hydrogen, as well as data available from technical surveys including gravity, magnetic, seismic and geochemistry. There are now multiple companies that are specializing in using AI to identify the best areas for exploring for geologic hydrogen. One of the companies that is specializing in this area is Rubicon Exploration. Along with AI, they have developed and utilize additional technologies to help explore for this type of hydrogen. Once AI has identified the best areas for exploring for geologic hydrogen in a selected country, these areas can be surveyed with a technology to help identify the best locations to explore for this type of hydrogen. This technology is called Raman Laser Light Detection and Ranging or LiDAR, and it can detect hydrogen at a distance. Excalibur Smart Mapping is now in the process of commercializing this LiDAR technology. As a result, combining this technology with a small airplane or drone enables a low-cost way to find hydrogen that is seeping out of the ground. Once the best locations for geologic hydrogen have been identified, utilize AI services to create data files that can be viewed in a selected data visualization software from available data including from LiDAR, gravity, magnetic, seismic and geochemistry surveys as well as borehole logs. Then, import all the relevant data into the selected data visualization software. Finally, invite a team of experts including geologists to view the data in visualization software to identify the best locations to start exploring for geologic hydrogen. Shown here is an example of a visualization of geological data that was generated by Rockworks 2022 software from rockware.com. Although this example is showing the visualization of a petroleum reservoir, this type of software is very useful for experts who are seeking to identify the best locations for geologic hydrogen. To help identify the best areas to explore for geologic hydrogen around the world, we recommend the following information be generated with the assistance of AI services. First, using AI services, analyze accessible land areas of the world to determine an initial set of 10,000 areas that can be surveyed from the air and reviewed by experts to determine the best 2,000 locations for exploring for geologic hydrogen. To make this information easy to view in Google Earth Pro, create a KML file containing this information for each country or countries in a region such as West Africa. Next, create additional KML files that includes data relating to each parameter identified in previous slides that can also be imported into Google Earth Pro. Then, invite countries with best areas to explore for geologic hydrogen to create an open bidding process to encourage companies to start exploring for this hydrogen. In addition, inform the private sector about the range of available technologies that can help them do so. As a result of the collaboration of many researchers in universities and companies around the world, considerable progress has been made in developing the best ways for exploring for and extracting geologic hydrogen. Since the geologic hydrogen industry is relatively new, much more progress can and should be made. Therefore, to further reduce the cost of exploring for and extracting geologic hydrogen, increased investment should be made in research and development to improve methodologies and related technologies for these activities. These improved methodologies can be incorporated into AI models to make them more effective in identifying the best locations to explore for geologic hydrogen. To accelerate the exploration and utilization of geologic hydrogen, a major effort to create more awareness of the business opportunities relating to geologic hydrogen should be implemented. This effort could include creating an increased awareness of the current gold rush amongst a relatively small number of companies that are currently searching for geologic hydrogen to pique the interest of many more companies, investors and economic development agencies. Then share results that were generated from AI data analysis with governments, industry and investors. As well, awareness should be created about how additional hydrogen can be produced in iron-rich rock formations, which is referred to as orange hydrogen. Then create awareness of how geothermal energy can often be obtained from the same wells that are extracting geologic hydrogen. To further increase interest in geologic hydrogen, create awareness of how this hydrogen can be utilized by proven technologies to produce a range of valuable products such as reliable electricity, commercial-grade hydrogen and methanol. There are multiple steps to estimate the amount of geologic hydrogen available in a selected location. Given below is an outline of a program to do so. In Phase 1, make a thorough review of the places to explore by studying data and geological maps in the selected areas. Then select the best locations to start sampling soil and fluids. In Phase 2, complete laboratory testing of samples from selected locations. In Phase 3, complete initial drilling and testing the wells for hydrogen. Finally, in Phase 4, perform full field development by drilling sufficient wells for delivering geologic hydrogen gas to market. Fortunately, helium is often found along with geologic hydrogen, which can make the exploration of this hydrogen a lower financial risk and more profitable since helium is a very valuable commodity. For example, Gold Hydrogen in Australia has estimated that they found approximately 41 billion cubic feet or BCF of helium along with 1.3 billion kilograms of geologic hydrogen in the area they are exploring. The U.S. Geological Survey has reported that the price for private industries grade A helium was approximately 39 United States cents per cubic foot in 2023. At this price, 41 BCF of grade A helium is worth approximately $16 billion US. There are a considerable number of organizations and events focused on geologic hydrogen. Given below are some examples. First is the drilling for hydrogen in September 2024 in Houston, Texas. Then is a conference by the Natural Hydrogen Association of Australia in October 2024 in Adelaide Hills. Next is the HNAT 2024 World Summit in Paris in November 2024. Finally, the 2025 North American Helium and Hydrogen Conference in April 2025 by the Rocky Mountain Association of Geologists. Geologic hydrogen can be a key component in providing needed energy when there is no wind or solar energy available, which enables the combined system to provide cost-effective, reliable electricity. For example, Shown here is a facility that combines wind and solar farms with energy storage and a generator running on geologic hydrogen to produce reliable electricity. Geologic hydrogen can be combined with a biomass power plant to produce reliable electricity, biochar, hydrogen and methanol as shown in a schematic on the next slide. Methanol is currently being produced from hydrogen and CO2 in several places around the world on a commercial scale. The hydrogen extracted from the earth would be transferred to buffer storage tanks, which would then be fed to an electricity generator and a methanol production system. The biomass power plant shown in the next slide produces electricity, biochar and CO2. Shown here is a schematic illustrating how to combine geologic hydrogen with a biomass power plant, an electricity generator and a methanol production plant to generate reliable electricity, biochar, hydrogen and methanol. The CO2 produced by the biomass plant is captured and is then combined with hydrogen to produce methanol. To increase resiliency of this combined system, buffer storage tanks are used to deliver hydrogen as needed to other processes in this system. The energy storage system enables electrical power to be stored and then sold to the electric grid when prices to purchase this power are elevated. Recycled carbon methanol is a general term for methanol produced from captured CO2, which includes the more specific subtypes such as green and renewable methanol. This climate solution is already growing rapidly and can be implemented on a large scale. It is produced from CO2 and hydrogen and can be used to replace fossil fuels as well as make products like plastic. Shown here is a commercial-scale recycled carbon methanol plant in China that produces in approximately 110,000 metric tons of this product each year. Carbon Recycling International has built this plant and is developing several more in other countries. The demand for renewable methanol is growing quickly. For example, the global shipping company, Maersk, announced it is planning to purchase 730,000 tons per year of renewable methanol by end of 2025. This amount of renewable methanol will effectively reduce the emissions of their shipping activities by about 1 million tons of CO2 per year. The demand for renewable methanol is growing very quickly. For example, according to BIS research, the global renewable methanol market is projected to reach $3 billion by 2031 from $0.12 billion a decade earlier, which is a compounding annual growth rate of in the range of 40%. Since methanol can be transported and stored economically, it can be a key component in providing needed energy when there is no wind or solar energy available, which enables the combined system to provide cost-effective, reliable electricity. For example, shown here is a facility that combines wind and solar farms with energy storage and a generator running on recycled carbon methanol to produce reliable electricity. Existing internal combustion engines can be upgraded to run on methanol at a relatively low cost. Kits can be purchased online to convert a gasoline engine to run on methanol. Converting diesel engines to methanol requires additional modification. One company that provides this service for large engines is MAN Energy Solutions. As well, new engines can be purchased that are designed to run on methanol. For example, shown here is a methanol-fueled engine by Wärtsilä. Methanol can be used to power remote electric vehicle charging stations. Shown here is an example of a methanol-powered remote electric vehicle charging station. Wind and solar energy can be added to this charging station to reduce the cost of the electricity provided by this charging station. A substantial amount of geologic hydrogen could be used to produce ammonia. For example, a research paper published in Sustainable Energy and Fuels reports that most of the nearly 180 million metric tons of ammonia produced globally every year are generated via reforming of natural gas or coal, resulting in approximately 500 million metric tons of carbon dioxide. 80% of the ammonia manufactured globally today is used in agriculture by farmers as a nitrogen fertilizer. Ammonia is used as a chemical ingredient in many industries including wastewater treatment, refrigerants and pharmaceuticals. In addition to being used for fertilizer and as a chemical ingredient for industry, ammonia can be used as a fuel. Shown here are two devices that can be powered by ammonia. The first is a fuel cell and the second is an internal combustion engine developed by Wärtsilä. In conclusion, based on rising global CO2 levels, the total energy demand appears to be rising faster than renewable energy generation, which is creating an urgent need to accelerate generation of clean energy. The U.S. Geological Survey has estimated that there is over 5 trillion tons of geologic hydrogen in the Earth. A portion of this hydrogen can be extracted and be used to generate electricity and create other valuable products such as methanol using proven technologies. Methanol can be used for many beneficial purposes including powering cars, trucks, heavy machinery and ships, enabling renewable energy facilities to provide more reliable electricity, and powering remotely located EV charging stations. As a result of the vast amount of geologic hydrogen available and that it can be utilized effectively with complementary technologies, it can play a key role in accelerating the global energy transition to a low-carbon economy. To accelerate the process of finding geologic hydrogen, AI services should be used to review available data relating to land resources around the world to determine the best locations for exploration. To reduce the cost of exploring for and extracting geologic hydrogen, increased investment should be made in research and development to improve methodologies and technologies for these activities. A global campaign should be implemented to create awareness of the huge economic opportunities relating to geologic hydrogen. This can include sharing with the public some key information about some notable exploration opportunities that have been determined from AI data analysis. To further increase interest in geologic hydrogen, create awareness of how this hydrogen can be utilized by proven technologies to produce a range of valuable products such as reliable electricity, ammonia and methanol. As the UN Secretary General has said, our world should take climate action on all fronts, everything, everywhere, all at once. Thank you for taking the time to view this video. If you are interested in more detailed information about these opportunities including links to websites of organizations mentioned in this video, please visit climatesan.org/atgh.